little video about pitfalls of logic. I want to talk about a little bit about and or, and also about quantifiers. So that's for every and there exists, and in particular, how much the order matters when you use these things. So here's a statement. I'm planning a vacation, and I'm talking about the vacation I'm going to plan. And I say I'm going either to New York City or Los Angeles, and I'll either visit the Hollywood Walk of Fame or the Statue of Liberty. So as written, this is a completely plausible plan because we've got an or that I'm either going to New York City or Los Angeles. Okay, that's plausible. Okay, and another or in here. So the and is the outer level, and the or is inside here, and then there's another inside here. This or is plausible, and this or is plausible, and so the and is going to be plausible. Okay, so this is something that could happen, but let me reverse the order. I'll call it 1 prime. Okay, either I'll go to New York City and visit the Hollywood Walk of Fame. I'm going to put that in. Ooh, and I should not abbreviate the and. The and is crucial. Or I'll go to LA and visit the Statue of Liberty. All I've done is I've taken these 4 statements, go to New York City, go to LA, visit Hollywood Walk of Fame, visit Statue of Liberty, and I've just exchanged the ors for ands. So the outer layer now is an or, and inside these parentheses, I've put an and these don't make any sense at all. You're not going to go to New York City and visit the Hollywood Walk of Fame. You're not going to go to LA and visit the Statue of Liberty. So neither of these makes any sense, so the whole thing isn't going to happen. So this is an example where it's crucial that this statement was very, very different from this statement when the and was the outer layer and the ors were inside versus switching them. It's really, you're always going to change the sense of a statement when you change the order of an and an or that are combined. Okay, so rather similar to that and related to that is the idea of what happens when you switch the order of quantifiers. So these are the phrases for every, like it was called a universal quantifier, and there exists, which is an existential quantifier, and they talk about that in the book. And so let me talk about statement number 2. For all humans, well, so for every, I want to actually have a name. For every human being X, there is a human being, not necessarily living, such that, and the there is always accompanied with a such that. There is a something such that something is true. You don't just say there exists a human being and then leave it at that. There exists a human being such that Y is the mother of X. Okay. Let's think about whether we think that's true. For every human being, there exists a mother Y. So every human being has a mother. I wanted to write it out in this a little bit more formal logic way because I wanted to be clear about how the quantifiers are coming in. So every human being has a mother is what that means when you express it in sort of more natural language. Okay, what would happen if you reverse the order? There is a human being Y such that, I'm just going to say ST for such that, for every human being X, Y is the mother of X. That's a very different statement. That's a very different truth value in the real world. This is saying that there's one particular person, one particular human being, who's the mother of every human being, including herself, as it turns out. Okay, so this is just totally false in the real world, whereas this is true. And they're not just, they don't happen to be, I mean, they're just very, very different statements. This is very, very different truth value. And this is just going to bug me, isn't it? I bet that's going to come back. Oh, maybe not. Yeah, we'll see. So, so this is a good example. All I did was I switched the order of the quantifiers, the there exist and the for every. Very, very, very different statement. Okay, and it's not an accident that this has a similar effect in terms of drastically changing the truth value to switching and or, because you could actually think of the for every as a gigantic and, basically. It says, it's true, this statement, whatever's going to come after this, is true for human being Bob and human being Jill and human being Alice and human being Eve. It's saying no matter what human being you pick, it's true, and it's true for this one, and it's true for this one, and it's true for this one. The there is says, look at all the human beings. Let's say once you picked Bob and you want to say that Bob has a mother, then it's either true that Alice is Bob's mother, or it's true that Eve is Bob's mother, or it's true that Charlie is Bob's mother, or, and you go through the entire set of human beings, and you're asserting that at least one of those statements is going to be true. So the for every, or for all, that's symbolized by this upside down capital A symbol. That's essentially like a massive and then the there exists, that's symbolized by this upside down backwards capital E, and that's very much like a massive or. So they have similar kind of properties logically. Okay. So let me just give you one more example. It's more mathematical. Okay, where would this come up in like number theory? For every integer, doesn't really matter, integer, real number, rational number, x, there is, but we'll stick with integers because it's a number theory class, there is an integer y with, and the with is maybe a little tighter way to say such that, okay, with x plus y equals 0. Let's see if we think that's true. For every integer x, there's something that if you add it, you get 0. Yeah, and namely, it's called the negation. It's a really important thing. You can negate things. Now, if I had said a natural number or positive integer, then this would not be true. Or, well, positive integer right here. Okay, you have to allow negative numbers for this to work. Okay, but this is a really important fact. Okay, now what happens if we switch the order? There is an integer y such that, yeah, I pretty much have to use such that, I can't use the with there, such that for every integer x plus y equals 0. This is quite a different statement. There's one and only one integer. Why? I picked that first. 7, I don't know. Such that it's the negation of every other integer including itself. Okay, this is just ridiculously false. Okay, so this is true and importantly true and super useful, and this is just utterly false. They're very, 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 very different statements. But there's no way there's one integer that works for everybody. Okay, so these statements tend to be a little bit more common in terms of mathematical theorems that we want to prove. We start out with universal, so it has lots of wide applicability, and then for every choice of input, there's something that behaves well with it and kind of matches up to it. Very common. These statements are a bit less common. There's definitely statements that start with a there is, but it's kind of weird sometimes to start out saying there is some special dude, and then it works for everything else. So it's a kind of, it has a very, very different feel. Okay, so the main point is it very, very much matters what the order is in terms of ands and ors and quantifiers.